Do you? All right. I'm ready. Questions. Let's start with the end of section A. If you have any A's that did not get covered yesterday. On 29 on Saturday? All right, guys. Shh, I'm not going to compete. So I'm the one up here explaining. If you are not staying busy with what I'm doing, you do your own thing. Open up your phone, open up the additional practice exam. You're like, I don't have a phone or the additional practice exam. You should have printed it off last night. We're doing number 29 on 2017 right now. And as soon as I finish this one, the next question that I see, the next hand that I see, just be ready. Tyler. Yeah, okay, so shh. All right, number 29. Guys, I love this question. I literally actually would love for you guys to take something out of this question and put it in your when you see you think. I'm not saying every year they trick you with this one, but I've seen it multiple years. Not this specific question, but the idea in it. Okay? They're asking you for two things. Horizontal asymptote and vertical asymptote, right? Help me out. This is in the when you see you think. It has to be in the pre-cal section. Guys, I'm not kidding. The when you see you think, the pre-cal section. Okay? It might be good to add to your when you see you thinks. How do you find a vertical asymptote? When the bottom is equal to 0 and the top is not. What if the top and bottom are equal to 0? That's a hole. Okay, so if the bottom is equal to 0 and the top is not. Now the nice thing is all the tops are 1, so there are no holes. Okay, no vertical asymptote. That means when you go to set the bottom equal to 0, when you go to set the bottom equal to 0, some of these won't work. I'm doing the bottom of the pitchfork. Can you add 1 and take ln of both sides? Yes. As a result, that one has a vertical asymptote. Can you subtract 1 and cube root a negative? Yes. Therefore, this one has a vertical asymptote. Now pause. If you were to solve x squared plus 1 equal to 0, you would get x is equal to plus or minus square root of negative 1. Is that a vertical asymptote? It's imaginary. I can't have square root of a negative. Does this have any vertical asymptotes? No. How about the bottom one? You would have ln of negative 1. Is it possible to have ln of a negative number? No. So neither A nor D have a vertical asymptote. So far we've dealt with no vertical asymptote, narrowed it down to A and D. Now horizontal asymptote. This is the key. This is the when you see you think idea that I need you guys to be careful of. When you see horizontal asymptotes or limits to infinity, hey, isn't limit to infinity how we find a horizontal asymptote? Yes. You always need to beware. I would put this in your when you see you think. Any exponential piece. Beware any exponential piece when you're taking a limit to infinity and or checking a horizontal asymptote. And here's why. The limit as x goes to positive infinity of an e to the x is positive infinity. But the limit as x goes to negative infinity, the negative is in the power, which means it'd be e to the negative infinity. So I could say it'd be the limit as x goes to positive infinity of 1 over e. Because e to the negative pops it down. That's going to be 0. E to the x behaves, any exponential expression behaves differently, whether going to positive or negative infinity. Positive infinity, it will grow. Negative infinity, it will shrink. Why am I saying that? If we go over here and look for a horizontal asymptote by only taking the limit to positive infinity, this one, here. Oh, they're both the same. Neither of them have vertical asymptotes and only one horizontal, only one. Wait, exponentials behave differently. We also have to check the limit as x goes to negative infinity. Because negative infinity would be the same thing as going to positive infinity when flipping the exponential. Now what's this going towards? 0 and 1 over 1. This guy has 2 horizontal asymptotes, not 1. This one, if I went to negative infinity or positive infinity, plug them both in, it behaves the same way. Bottom wind's still 0, so this one only has 1, whether you go to one direction or the other. But exponentials, here's my beware, here's my I would put it in your when you see you think. Here's the sad thing. Only one person's actually finding that worksheet. Okay. Well, I try my best. I lead you to water. It's up to you to drink. 2 people. Thank you. 3 people. All right. Tyler. 4 people. 78. Hold on. Section A. Section A. Any more section A's? 17 on Saturday? 30 on Saturday? Okay, let's do 30 because we're real close. So we'll go back to 17. Okay, 30 is a great concept question. Okay, now hold on. I need you to think English. Okay, careful. Think English. All right? Thinking in English, something is this expression. You got to look back in the sentence to figure out what is the subject of this sentence. Who is 2 times n plus 1 over 3n plus 2 n squared? Going back, equal length, subintervals? No, why would the subintervals be that? Subintervals with. Oh, hey, this is a prepositional phrase, with. Okay, forget that. That's not the subject. Oh, the integral must be. No, that's in a prepositional phrase. Okay, keep looking back for the subject. The right Riemann sum approximation is that. This was just describing, this is, technically wouldn't it be the, wow, did not know I would forget that. The predicate nominative, is that right? Anyway, sorry. I did a lot of grammar in high school, but for some reason it's failing me now. So, these are synonyms of each other, basically. The identity of this is that, the identity of this is that. So this is the subject, this is the, direct object? No. Wow, it's gone. Anyway, I think it's predicate nominative. So, as we're looking at the 2, they're asking me for the actual integral. Well, hold on. Doesn't a right Riemann sum only approximate? What's this based on? This is based on n. N stands for n subintervals, aka n rectangles. Well, hold on. How can I take an expression built on n finite rectangles and make it the actual integral? What is the definition? The Riemann sum definition of an integral. That's a forever card. Not the summation only. The limit as n goes to infinity of the summation of n rectangles. Is this a forever card? The limit definition of an integral? So I can take the Riemann sum approximation and say, oh, well, if I could just approach infinite rectangles. Come on in. Do you need your quiz? It's right in the back. She wants to make sure that you remember to label all the graphs on the graph paper. Okay? On the back table. I think it's waiting for you. Thanks, bud. The limit as n goes to infinity of 2 times n plus 1 times 3n plus 2 all over n squared will equal. This is basically the limit of the Riemann sum, but they gave us a nice, pretty formula. It's very nice. Because we're going to infinity. And how do we go to infinity? Degree test. And how do we do degree tests? Well, we check out what this ultimately would be. Isn't it ultimately going to be a 3n squared times 2 is 6n squared? Degrees are tied. And what's 6 over 1? Dun, 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 dun. But pause. Was there a forever card? Yes. How do I solve an integral if I have a Riemann sum approximation? I take a limit as n goes to infinity. Guys, this is a new type of problem that's showing up, not this one specifically, but a type of problem, like a category problem that's showing up on newer APs and not older ones, where it says, hey, we're going to give you something totally possible to solve, but makes you dig deep in the concept. What do you need to dig deep in the concept? Those forevers. Not just like strict memorization, but understood comprehension. Does that make sense? Okay. Great question. Thanks for asking that, Caitlin. Let's go back to number 17, right, Austin? Yep. Number 17. 2013, 2017, we're about to transition to letter B. So if you guys have any last-minute A's, have them ready after we go over this one. Oh, nice. It's a slope field.
Wait, 17.
Oh, 17. I was like, oh, I like slope fields. But I hope that you like them too, so that's why I was like, oh, we have a question on it? Okay. Austin, what do you see? They give us what? Good. And they're asking us about what? Now, velocity is 0. Couldn't they also have said something about at rest, like in a different problem that needs the same math? Okay, but they didn't. They said velocity is 0. So to find velocity is 0, everybody, what do we got to do to position? Derive it. Everybody, why am I doing a box and a triangle? Because it's times. Do I care about the 12? No, it's a constant. No big deal. But I do care about the e to the negative t times. If anybody's making mistakes on product rule, get to your when you see you think. Get a colored pen out. Go find the product rule and make a big point of, I don't know, writing lots of examples down and drawing boxes and triangles and saying box, triangle, box, triangle. Because you're going to have to do for v of t, which is x prime, second, d first. Derivative of e to the u is e to the u, remember the constant stays, times u prime. Plus first, d second. Is anybody mixing up sine, cosine, positive, negatives, derivatives, and integrals? Careful. Derivative of sine is a positive cosine. Integral of sine is a negative cosine. If you have your derivative rules down really well, integral is just the opposite. Derivative sine, cosine, derivative cosine, negative sine. And integral, you just have to think opposite. But aren't we supposed to set this equal to something? Ugh. Can't we plug out, or pull out, I should say, the negative 12 e to the negative t? So that's gone, I have sine. Minus cosine. Quick hint, if you want to put it in your when you see you thinks, you can. An exponential will never equal 0. It can't. If you try, you'll end up with ln of 0, which does not exist. An exponential will never equal 0. I mean, if there's like a plus or minus and it ends up equaling something other than 0, I could solve. But it's impossible for this guy to be 0. So, who am I looking at? This guy. This guy will be 0 when sine equals cosine. And when does sine equal cosine? At a pi over 4, of course. Square root of 2 over 2. Square root of 2 over 2. The one place. Well, couldn't it equal in the first quadrant or the? Because negative, negative, positive, positive. But this is second quadrant. That's not even a pi over 4, neither is that. Good? Any more section A? Of the additional practice or the mock? On Saturday? Okay. Number 18. Guys, just a quick heads up, period 6, I think more of them had to do the Monday exam. So if some of you haven't fully attempted the practice exam, they're asking a lot of questions from 2013, so feel free to check it out. If you took the Monday one or if you haven't done the practice one yet, the additional practice. Number 18. What do you guys see? We have him. Who do we want? Good. What's the calculus? Take a derivative. If you need to, can you write it out? Yes. And if you write it out, what should your brain be ding, 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 dinging? FTC part 2. The derivative of an integral from a to u is f of u. Don't worry about the 3. It could have been a 10, a 17, a pi. I don't care. A to u, plug in the u. So I have tangent of 5 times who? X. Secant of 5 times who? X. Minus 1? Uh-oh. Did I? There we go. Wait a minute. Times u prime. Good, Nathan. Well, wait. Who is u? U is x. So then u prime is just 1. Ah. Dun, 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 dun. Remember that a has no bearing. Because if you were to solve it, if you were to plug in b and plug in a, antiderivative of b minus derivative of a, and then take the derivative, any a that got plugged in, that derivative would be 0. So forget the a. As long as he's there, it's legal to go straight to f of u times u prime. Does that make sense, Sam? Any other questions on the a? Oh, I thought that was a question. Charlotte's just hair flipping. Okay, b. Let's do it. Now, b, he did. Charlotte beat you. She was ready to go. I'm pulling up my calculator. Pause. Get out your calculators. Some of you don't know how to use it as fully as you need to be able to, okay? So, pulling up. Number 79 was the first one that I heard.
On what one? Oh, Saturday.
I'm guessing Saturday, Charlotte? Charlotte, Saturdays?
Yeah.
Okay.
No, Monday.
Oh, Monday. Monday, number 79. Ooh, that's exciting. If you haven't done it yet, you have two options. One is go find a question you have on what you have done and wait until you try it and come check out the video. Or be realistic and be like, I probably would get stuck on it too. And then you can just do it with us. Okay, number 79. The figure above shows the graph of f prime. Now pause real quick. Is there anything to put into our calculators on this? No. But you're allowed to. There's nothing to do. So some of these questions don't need the calculator, but they decided to put it in the calculator section because they're nice like that. Anyway, that's okay. If everything was a calculator problem, you wouldn't have time to do them all. So, coming back. This is a graph of who? Graph of a derivative. Is that a big concept in calculus, given a graph of a derivative? Yes. Okay. So given a graph of a derivative, real quick, let me think through a few things. They gave me a point of the original. So I know the original has to start at 0, 0, but check it. Do all of these start at 0, 0? Yeah. The poop heads, we can't take anything out. Oh. If anything did start at something other than 0, 0, we could cross it off. Okay, cool. As I'm looking at this guy, the graph of the derivative, won't my critical numbers of f be the zeros and the DNEs? Yeah. Now, I don't see any vertical asymptotes, so I don't have any DNEs. But I do have 1, 2, 3, 4 zeros. Doesn't that mean I should have 4 horizontal tangent lines of my original? The derivative equals 0. The slope will be 0 of the original. So I should have a flat point at, if you want to think about it, 0, 2, excuse me, 3 and 4. Ooh, that was rough. Why am I crossing off A? I don't see a flat point at 4. Why am I crossing off B? No, I was going to do D. I don't see a flat point at 4. I see a sloped up. I don't see a flat. I'm crossing off B too. I don't see a flat point at 4. It needs to have gone flat in order for this to be a 0. Now, D? Yeah. Does it curl? Okay, we can reconsider. Well, I don't see 4 flat points on D, so we can cross him off anyway. I need 4 flat points, right? 1, 2, 3, 4. That one maybe, maybe. 1, 2, 3. Okay, we can look at D a little more. Maybe my picture is not as good as your guys's. I don't see it going. Oh, it's not flat here though. It's not flat there. Take that one out. Okay, this one I see flat at 0, flat at 2, flat at 3, and seemingly flat at 4. Okay. This one I see, I think, flat at 0, flat at 1. I don't want it flat at 1, do I? No, there's no 0 at 1. Don't forget him. Ah, dun, 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 dun. Now, hold on. If you're like, but wait a minute. You could also think, whenever the derivative is above, what would the sign be? Positive. So I know that f prime is positive because it's above, and then it goes below, and then the derivative goes above. I don't know what's going on here. Shouldn't I see a maximum and a minimum, a max at 2 and a min at 3? Max at 2 and a min at 3. Dun, 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 dun. Okay. Number next one. Tyler, you had one.
Oh, yeah. 78 on the Saturday one.
Saturday, number 78. 2017. On this one? Okay. Number 78. The continuous function is positive and has a domain x greater than 0. So that's our domain. Who is that? That's f. If the asymptotes of the graph are 0 and 2, which of the following, the asymptotes, hold on, x equals 0, wouldn't that be a asymptote?
Yes.
Okay, and then y equals 2, that would be a horizontal asymptote.
Yes.
And we've talked about how horizontal asymptotes are limits to infinity or negative infinity. Okay, which of the following must be true? Kiddos, I would think about, if I were you, y equals 2, and then 0. And I know the graph always has to be positive, which means f cannot go down, right? And I'm only looking at this part of the graph because x is greater than 0. So forget all of that. Don't I have to be going into the asymptote going up? Because if I were to go down, I would have negative values. Positive, I need it to be above, the function to be above. And the only way to skim an asymptote above and not going below, it has to be going up. So I can say that the limit as x approaches 0 from above must be positive infinity because it can't go negative. So it's not going to be 2. It has to go to infinity. It's an asymptote. Where's another 0? 0 going to infinity, 0 going to infinity. This one doesn't even have 0. That's awkward. Limit as x goes to 2. D is the answer?
Yeah.
Yeah, I know.
Hold on.
That's what I thought. Because
Must be true. Hold on. Okay, hold on. Let's keep thinking. Because if you guys notice, so far I agree with this one, and I agree with this one. So far I agree with those. Now, as x goes to 2 of f of x is infinity.
That's correct.
As x goes to 2?
Yeah, that's the definition of limit.
The limit as x goes to 2 is infinity?
No, I mean, the go infinity is 2, but not 2.
Yeah, as we go to infinity is 2.
Yeah.
Okay, hold on. What is this, number 78? Let's make sure that I didn't bubble something wrong on my answer key.
Whoever graded the FRQ wrong.
78 is C. What did the answer key say? D?
Oh, thank goodness. I was so
No,
confused
it's C.
with this D. Oh, wow, you got it perfectly.
Almost. Okay, hold on, let me double check. Well, I apologize, guys.
I was so confused.
Those of you guys that got it right, I'm not inputting your final exam score anyway yet. In your colored pen, write on your Scantron or circle this problem if you did get C. The correct answer is C. Something must have gone wrong when I ran it.
What number is it?
Number 78, if you took the Saturday AP, check number 78 on your Scantron. If you put C, you were right. In your colored pen, circle that whole 78. And when I go back and when I grade on Friday or Monday, I will make sure that you get that point. Oh, all better. All better. Okay, David, you had one. Number
81
on Monday, right? Okay, number 81 on Monday. Ooh, I like it. It's like the biscuit and tea problem from a couple years ago. Cup of tea is cooling in a room that has a constant temperature of 70 degrees Fahrenheit. If the initial temperature of the tea is, I'm going to do T for T. Is that okay? So T of 0, the temperature of the tea is 200 degrees Fahrenheit. That's that clue. And the temperature of tea changes at a rate of, let's see, the room is 70 degrees Fahrenheit. I know my initial temperature. And I know that my T prime is equal to R of T, which is what they gave me. What is the temperature to the nearest degree of the T after 4 minutes? Integration as net. Because only that one says the time. If you just tell me what was happening at the beginning plus the integral of the change in time, which from this one would be 0 to 4, of the rate. So it'll give me T of 4. If I can plug in T of 0 plus the integral of the rate. Now guys, at this point, there is absolutely no reason not to use your calculator to solve. Here's the sad thing. I had some BC kids who were grading AB FRQs, where the AB kids solved a calculator integral by hand. That's a waste of time, and you probably made mistakes in the midst of it. So if you plugged and chugged 200 degrees plus the integral from 0 to 4 of that function, you should have gotten the correct answer of, I have no clue. Which one? A. Wait, and this is 2013, right? Yeah. Perfect. Thanks. Yeah. It depends on the setup of the problem, but for integration as net change, if you have a function and you're not making it, if you have a function of rate, you plug it straight in always with a plus. But now you can think of logically whether or not it makes sense, because it's going from 200 degrees, right? Like this morning, you get a cup of coffee. It's a certain temperature coming out. It's sitting in the room. What's going to happen? It's going to cool down. If you did the wrong sign, Charlotte, this would end up being a hotter temperature. Would that make sense? No. So if you did do minus the rate, which you're thinking it decreases. Well, no. It doesn't say decreasing by a rate of. It doesn't put the decreasing word and you need to put the sign. It just says here is the rate. You're like, okay, cool. Whoosh, whoosh. And the decreasing is already in it. Does that make sense? Okay. So if it says the word increase or decrease, maybe you have to put the sign in yourself. But this one just gives us the rate we plug in. David, that good? Okay, anybody else? B questions on either exam? 82 of this one? Okay. 82 on Monday. On Mondays, 2013. Oh, I like it. I like it a lot. Kiddos, can we just make sure we can use our calculator? Plug this function into your graph. That would be my advice. Plug this function into your graph. That would be my advice. Making sure we can use our calculators. Because remember, if we can, let's. Hopefully you're in radian mode. You're going to check that before you start your AP, just in case a pre-calc kid has borrowed your calculator. You put in this function of x cubed minus 4 sine of x squared. And here's why. This is asking us for, plus 1, thank you, a relative maximum. Some of you might be like, well, I'll just integrate it. Don't. It's impossible for you to integrate this by hand. Instead, if you just take exactly what they give you, can't you consider it as a graph of a derivative problem? And you can look at the graph of the derivative for the zeros, for the changes from above to below or vice versa. Now, hold on. They gave us one more thing that'll really help. I'm going to hit zoom standard just so that I can get it set to be like the normal window. But then, what did they tell us as far as the interval? Pause. If your calculator's ever taking too long, hit the on button. It breaks the coding. Now, coming back to y equals, why am I going to change the window?
So you don't accidentally...
So I don't accidentally go beyond the interval. So then I'm going to change my x min, x max to be negative 2.5 to 2.5. Now when I do that, what are they asking for specifically? Only relative maximums. Use your forever card. A relative max when using the first derivative, not the second derivative. A relative max when using the first derivative. I need a 0 or a DNE with a change in sign of the first derivative from. And when you're looking at a graph of a derivative, that's going to mean or be shown by going from above to below. Is there a 0 where the graph goes from above to below? Not below to above, those are minimums, but above to below. I see him. I want that guy. As long as you know how to use your calculator, all you have to do is go find the 0 and say, I want. And actually, guys, have I shown you this trick? If you see that you would get to the right by plugging in something like 2, you can plug in and tell them where you want the right bound to be. You don't have to actually scroll there. Uh-oh, but that's not good because 2's over there. So then I'd go back and I'd say, oh, I didn't do a good job. Instead, I want to go ahead and go from 0 to 1. Once again, can you use your scroller button? Yes, you can use your scroller button, but sometimes it's a little bit faster to actually type in values. 0.542 only. There were other zeros, but they were not relative maximums. So relative max, I need f to go from increasing to decreasing. So f prime needs to go from positive to negative. This is f prime. So I'm looking from where he goes. F prime goes from above, positive wise, to below, negative wise. Okay, we're looking at Saturday's AP. Number 81.
Specifically what?
Yeah.
Saying graph of an anti.
Okay, so the wording was weird on this one. This wasn't just like an f prime. They're making it a little bit harder as far as the concept. Oh, they're making you dig into the concept. So everyone, eyes on me. Antiderivative. When you hear antiderivative, what kind of problem are we usually doing? An integral. Okay, so you have integral of f. Antiderivative is this guy, right? According to our forever card on FTC, the antiderivative, couldn't it be written as Isn't that true for an antiderivative? The antiderivative is the guy whose derivative is the little f, or the integrand. So if I'm looking for this, what can I think of this guy as being? I can think of him as being the derivative. Or I'm looking for this guy given this guy. So I'm looking for the antiderivative given the derivative. Does that kind of make sense? So this is ultimately a lot like the problem we just did, just the wording was all funny and weird. So we're trying to go ahead and find which of the following could be the antiderivative graph. Well, couldn't I find the zeros? Couldn't I look for HTLs at plus or minus 1.5? And couldn't I say, hey, an HTL, hey, an HTL, uh-oh, uh-oh. I'm not supposed to have another one. There's no zero there. Okay, forget him. HTL, HTL, uh-oh, uh-oh. I don't have two zeros there. HTL, HTL. I don't have two zeros. What are they doing? Look at all these HTLs they're putting in. HTL, HTL. Guys, do you see how easy they're making these because of how hard the wording is? This is the only one that has two HTLs. Now you can think about the movement as well, like below to above. So the derivative is negative to positive. My function needs to decrease, increase. That's a relative min. Then it goes from, the derivative goes from positive to negative. So the function needs to go from increasing to decreasing, relative max. Is there some variance and some weird, like, in between? Yes. But there are only how many HTLs? Two. Other B questions on either exam?
87.
On which one? 87 on? Sorry, Charlotte, which one? Same one. 87 on this one. And then Sam, you had one next?
82.
Okay. Yeah, don't get lost. 87. I think we're on the, which one is this? Monday one? Saturday one. Thanks. 87. Okay. Now, there's something very important for you guys to see here. This one says could be true, right? Could be true. Doesn't have to be true. Because when you have a table, you don't know for sure that it only decreases, only decreases, only decreases. Like, I don't know that for sure, but I know that at least for some place, there has to be some decrease to get from here to here. There has to be some decrease. MVT says if the average rate shows an average decrease, there had to be an instantaneous increase or decrease somewhere. So MVT says if the average is a decrease, there has to be a place where the instantaneous is. So it had to decrease at least once, at least once, at least once. So it had to decrease at least part of this. So right away, can I say that it could be increasing? According to my data, no, it could be decreasing the whole time. So forget that guy.
Yeah, and the answer is B.
Wait, is that also B?
Yeah, the answer, the right answer is B.
Oh, F prime. No, my bad. What did I just do? I used the word increase because I'm thinking decreasing. I didn't give subjects or nouns. English. Who's decreasing?
F.
Would have taken me a while to figure that out. This is F. So what's F prime's sign at least once?
Negative.
Okay, so sorry. Take out the positive. Lo siento, that was totally my bad of not reading the problem. F is decreasing. on maybe all of it, at least some of it. So f prime is negative on maybe all of it, at least some of it. Okay, now pause. F prime is negative. We're down to 2. Now, f prime decreasing and increasing. F prime, the rate. Okay, so I know that f prime is negative, at least part of it. I need to figure out what the rate is doing. Kiddos, rate of change tells us for every unit of change of x, how much the y's go down. Okay? So dy dx is telling us the change or the rate of change in units y per unit x. So think miles per hour. How many miles change per 1 hour of time? People per day. How many people are changing per day that passes, etc. So in this one, how many units of y are changing per unit of x? So I'm going to look at the jumps and say, okay, we'll get from 9 to 4. Isn't that a jump of minus 5, the average? 4 to 0, isn't that a jump of 4, the average jump? Then a jump of 3, then a jump of 2.
Why is no negative?
If, because negative 3 minus 2 is adding a negative 2. So 9 minus 4, 4 minus 0. The average rate is going to be negative because I know that the function is decreasing. But then don't I also see the function is decreasing? Don't I also see the rates seem to be, wait, negative 5, negative 4, negative 3, negative 2. The rates are increasing because they're getting closer to 0 or more positive. Closer to 0 or more positive.
You use 4 minus 9, not 9 minus.
Right, because to get from here to here, because we always move forward in time. So the average rate, f of b minus f of a, all over b minus a. But Charlotte, even if you did it the other way, wouldn't you technically have done 9 minus 4 all over 1 minus 2? Still would have been negative.
No, I'm doing like 9 minus 4 is 5.
Ah, 1 minus 2 though. You would have had to think about the rate. Does that make sense? So f of b minus f of a all over b minus a. Sam, you said number 82? Okay, we're on 82 on the Saturday one. People on the Monday one, feel free to get questions in. I know you missed things. Feel free. 82. No, both of you guys did. I'm just saying that it's fine for them to. Yes, period 6 is asking a lot of them, but. Sam, I have velocity. Yeah. Meters per second. What is the total distance? Hey, forever card. What's the total distance traveled given velocity? Integral from A to B. They give it to me. Absolute value of. Way. There is no by hand work to do. There is no by hand work to do. Can't you guys just go ahead and, isn't there a shortcut for derivatives or integrals? Number 4. Isn't there a shortcut for absolute value? If you don't remember the shortcut, it's also under the math, but there is a shortcut alpha window for the absolute value also. But guys, where else do you find the absolute value if you don't remember the shortcut? Math, number. It's right there. It's right there. Then what would I do? Carefully, carefully, carefully plug in the function. I'm trying to think if there's anything that could get messed up on this. Be careful with your exponentials. Oh, struggle. Be careful you're putting it in the right place, number 1. Be careful with your exponentials. You guys know you have to hit the over button to get out of the exponential, right? So you have negative t over 2, then hit the over button to get out of that. Then go ahead and hit your sign of whatever's going on, 2t. You can totally use x's, no stress on that. End your parenthesis, you're in the absolute value bars, and it should be good to go as soon as you put in the dx. Is that cool? Yeah. Can anyone find me a place on the section B, not FRQs, multiple choice, where you needed to use your calculator or should have used your calculator to find a derivative? Not an integral, a derivative. Because a lot of people would do it by hand, and they're going to make mistakes when they do it by hand. The calculator can do it for you.
I think 88.
88 on
Saturday.
On Saturday.
I think that's one we got to do.
Let's go check number 88 real quick. Huh? Okay, cool. Thanks, David. Okay, that'd be one way.
Oh, well, that's not, I don't know.
That'd be one way. This one says line tangent, and then the line tangent. Guys, for lines tangent, don't I need to go ahead and plug in stuff? Now, wait. Parallel. What does parallel mean? Same slope. So can't I say, when will the derivative of 2 because it says at 2 for f, right? Equal the derivative at a. Because this one's at a. So, good. I just want to show you this one. The derivative really wasn't that bad. It really wasn't that hard, but sometimes there are much harder derivatives. I just want to remind you guys, your calculator can find a derivative if you have a number. Because you can go ahead and use alpha window. You can use the n-derived feature. You can and should use your calculator to find derivatives when you're allowed to use your calculator of functions just to be safe. And just a hint, sometimes these are a lot nastier than this one. This one's not too bad, 1 over u times u prime. But ln of x squared plus 1, my such that would just be 2, right, guys?
Yeah.
So my calculator can do this for me. Now the struggle is that they made it so that I can't do it entirely with my calculator. Lame sauce. But I can go ahead and take this and then set equal to, okay, I have to find the derivative of g by hand. What's the derivative of g? 5x to the 4th plus 3x squared, right? I'm setting equal to this guy, 0.80000. Okay, there's so many zeros, let's just do 0.8. And then, David, bring that question tomorrow so we can start there, okay? Can't I graph and find the intersection, guys? Remind me to pick up with this one tomorrow because it's a great question because I'm not sure all of you could have graphed and found the intersection quite so well. All right, cool kids, tomorrow, what are we doing? Finishing B, FRQs 1 and 2 of the mock and the additional practice. All right, cool kids, I'll be here after school if you need something. I should be here during lunch, but we're doing mission pictures, just a warning.